Dr. Russell said. Ooh. Oh. Today, again, everyone, we're doing acids and bases today.
Good audio.
Let me know if you can't hear me too clearly. And give you what we're doing.
No, this audio is great. Wherever you are, whatever you did, just do that.
Okay. All right, so the first one I would like to so that when I go to the report. It's just part A, there's two tables. One, two, one. Part A, label those two tables. Table 1, table 2, right? Then part B, table 3, call that table 3. Part C, table 4. Part B, 1, table 5. Part B2, table 6, 3, tables 7 and 8. Okay, so those tables are known. That's all for you. All right, table 1. It's still muffled. Let me see how. Can you all hear me now? How is it? Okay. Mic check. Can everyone hear me? Is it muffled or can you understand what I'm saying? It's going in. All right. How about now? Okay, clearly. All right, part A, table 1, you need to put in your own estimate. You can indicate for the 1 and 2, 6 compounds that are listed. Okay. You think it's an acid, it's low pH, if you think it's a base, it's going to be a high pH. So again, make sure I can't do that. Okay, we're still experiencing some audio difficulties working. One moment. Sorry, y'all. Can you hear me, Dr. Russell?
Yeah, I can hear you. So you can run the meeting from the laptop, but just use the phone for the audio. So you're gonna have to, if your audio is on your laptop too, you're gonna have to mute everything. That way you won't get that feedback. So the only source would be the phone for audio, and then you can run the video from the laptop. If that makes sense. Yeah, because it's going to keep giving feedback. If there's any secondary audio source, it's going to keep feedback. So your laptop should be on mute, and then Jan's laptop is on mute, but the phone is not. Or yeah, whatever you run in Zoom on for yourself, you should mute it. So you only have one audio source.
Does that work?
Yes. Do you have another something else that's giving off audio? Like,
I mean, I got it.
so whatever that is, whatever second device that's you can hear me on, turn it all the way down so that you can only hear me on one device. And then we can hear you just fine without the feedback.
So like this?
That's perfect. That is perfecto. Yes.
Okay, hold on. Let me put this
Perfect.
on.
So you can put that anywhere close by Jan so we can hear Jan, and then we can run the video just like it's been going because the video was fine. It's just the audio is muffled.
Okay, is it good now?
Can you hear me now?
Oh yeah. Yeah, that's beautiful.
Okay.
Yeah, yeah, that's perfect.
So I was saying,
Yeah.
one part A, I'm trying to fill in table 1. That's your responsibility. You put your predictions for what the pH is going to be. And then what I'm about to do will help you fill out table 2. So table 2, we're going to use these strips of pH paper to measure the pH of those 6 compounds. And based on the pH, which will compare to a scale, right? You write A if it's acidic, B if it's basic, or X if it's a salt, which should be neutral, okay? All right, so the first solution is hydrochloric acid. Get my paper in there. This is the color I'm getting. There's a scale for comparison. Great. So it's the same color as what this scale says is pH. Okay, so table 2. The first measured pH is about 3. So you write A if that's acidic, B if that's basic, and S if it's neutral. Okay, that's the first one. The second solution is HNO3, nitric acid. There's the color, there's the chart for comparison. I'm seeing that it's like, let's see. But the color closely matches the pH2. Okay, so that second solution, HNO3, our measured pH is about 2. And then for classification, you write A if that's acidic, B if that's basic, and C if it's neutral. The third solution is phosphoric acid, H3PO4. This is the color I'm seeing. There's the scale for comparison. It looks about a 2 again. Okay, so for H3PO4, the measured pH is 2. pH values less than 7 are acidic, so H3PO4 is an acid. All right, let's do our next solution. H4Cl, that's ammonium chloride. I'm gonna put my pH paper in, get the tip wet. This is the color I'm seeing. And that lines up to, looks like pH 8.
Yeah, that one.
Up to about pH. So NH4Cl, the measured pH is 8. pH value is greater than 7 are basic, so that one will be basic, yeah. All right, the next solution, NH3, ammonia. You write your prediction. Ammonia is going to be acidic, basic, or a neutral salt. Now, here's the color I'm seeing. It looks to be like pH 12. So I'm just matching the color with the pH scale. Okay. Keep it going now. We're back, it seems. All right, so NH3, I mean, the pH was like 12, right?
Mhm.
So that would be basic of that. Then our last solution, NaOH, sodium hydroxide. That's the color I'm getting. That looks like all the way to 14. So, yes. So that last solution, NaOH, the measured pH we got was 14. That's the very high end of the pH scale, so that would be very, very basic. All right, so from filling in table 2, I hope we all agree that there were 3 solutions that were acidic, right? The first 3. HCl, which is hydrochloric acid, HNO3, which is nitric acid, and H3PO4, which is phosphoric acid, right? So those are the acids that we're going to use going into part B. All right, so you should have table 2 all filled out now. And we're gonna move on to part B. First, you're going to list those 3 acids that we determined from part A. So table 3, our first acid would be HCl. Then we have HNO3, and then we have H3PO4. Those are our acids, right? Then you're going to write a number, a predicted number of drops that you think it'll take to neutralize those 3 acids. Okay, so go ahead and put in those three acids, HCl, HNO3, H3PO4, and then put in the number of drops that you think, the number of drops of NaOH you think it'll take to neutralize those three acids. While you do that, I'm gonna add some indicator to those three solutions so that we can see the color change. All right, assuming we're good to go. I'm gonna start adding sodium hydroxide to HCl. Okay, if you can see, you can count the number of drops. Six. All right, so I don't know if you can see this. The solution has turned a very pale pink color. That pale pink indicates the endpoint of the neutralization reaction between that acid, HCl, and the base NaOH. The reason it's pink is because I added phenolphthalein indicator. Phenolphthalein is usually clear and colorless on its own, but it will turn pink once the endpoint is reached. So every time I add some of this NaOH, I know I've reached my neutralization point. I know I've completely neutralized my acid when it turns this nice pale pink. Okay, so for this first one, this first acid, HCl, it took 6 drops of NaOH. So the first number for actual drops, 6. All right, let's do our next acid, which is HNO3. I'm gonna go ahead and add NaOH. I'm gonna keep adding until I see that pink color again. 8, 11, 14, 15, 22, 4. Is you think here? One.
But at the top, like,
That's good. Okay, 26 drops. So as it says in the chat, for this acid HNO3, we needed 26 actual drops of NaOH to neutralize it. All right, let's do the third acid, which is phosphoric acid. Let's see how many drops we need this time. 2, 4, 6, 8, 10, 12, 15, I'm seeing them. Okay, so our third acid, phosphoric acid. How many was that? 18? 18 actual drops needed to neutralize HNO3. Okay, so you should have the first 3 columns for table 3 filled out. Those were the only 3 acids. So we're done with part B, okay? All right, let's move on to part C. Part C, again, you are asked to make your prediction as to whether those solutions are acidic, basic, or neutral. So go ahead, take a minute, write A, B, or N for your predictions for the solutions in table 4 under part C. A if it's acidic, B if it's basic, and if you think it's neutral. Just your prediction. And then we're gonna find out. Okay. If you have enough time to do that, let's get our pH paper again. And measure some pH values. 6. Static. Na2CO3, that's the first one. I don't know if you can see, but I'm dipping my pH paper in there. There's the color it came out. Comparing to my pH scale. That looks like pH 11. Okay, pH 11. So Na2CO3, that pH came out to be 11. You write if that's acidic, basic, or neutral. The second solution, NaHCO3. Sorry. Yes, NaHCO3. Oh, I think that's supposed to be NH4Cl. Okay, there's a typo in table 4, it looks like. That second solution should be NH4Cl, ammonium chloride. So make sure you correct that. Again, table 4, NH4Cl. That second solution should be NH4Cl. At least that's what the procedure says. All right, so make sure you correct that. And I'm gonna go ahead and test the pH. All right. Here's the color that I got. Brownish yellow orange. That looks like pH 6. That looks like pH 6. All right. Next one, NaCl. NaCl. See what color we get here. Oh no. All right, here's the color of any pH paper for NaCl. That also looks like a 6 to me. Yeah. So pH 6 for NaCl. Next solution, iron chloride, FeCl3. Got a nice deep red. Could be like pH 2. All right, and then the last one, NaH2PO4, sodium dihydrogen phosphates. The color orange. What does that look like to you? 4, 5, 3. Say 4. This one seems close to H4. Actually, what I'm seeing. So that last solution, NaH2PH4. Right. Which one? The next one? Na3PO4. My bad. All right. Thanks so much for catching me. So I did skip Na3PO4. So let's do that one now. Color looks like H12 to me. All right, so Na3PO4, pH12, and what was the one? The NaH2PO4. What was that one? pH 12. 12. Okay, so we're done with table 4. You have the pH values. Go ahead and use those to classify them as acid, basic, or neutral solutions. Let's move on to part D. Part B1 is where we fill in table 5. There you go. Six molar. Do you see 6 molar HCl over there? Oh. Okay, 1 minute. I think I know where it is. I'll need the raffles. That rack, label C. I need it back just for some empty tubes. Same. Part B1 to the 5. I'm about to pour some very concentrated HCl tubes. We're going to see how it reacts with 3 different metals, okay? Okay, so our first metal to react with is gonna be zinc. Big bottle of zinc here. All right, so I've added a piece of zinc to the concentrated acid. Look on the screen to see what's going on. This is the reaction between those two. It's bubbling really intense. I don't know if y'all can hear the fizzing. I can see some gas coming out the top of the tube. There it is. There it is. So there's some gas being involved. That's why there's bubbles. The solution isn't changing color. But this is what happens. This is the reaction between zinc and hydrochloric acid. The tube is also a lot warmer right now. So under your observations, you can write heat formed, bubbling, gas produced, fumes escaping, however you want to phrase it. Okay, y'all see that? As time goes by, the reaction's going to get less intense as the metal gets used up. All right, I hope you see that. I'm going to put it down. So that was the reaction between concentrated hydrochloric acid and zinc. Let's see how it reacts with magnesium. So the same acid at the same concentration, just a different metal this time. So that was a really violent reaction. The bubbling was intense. The tube is extremely hot right now. I don't know if you can still see the gas forming, escaping from the top of the tube. Very intense bubbling. The magnesium was a gray color, just like the zinc. So that's why there's all this gray stuff at the bottom of the tube. So your observations, intense bubbling, lots of heat evolved, lots of gas produced. All right, I hope we got that. All right, then our third metal to react with this acid is copper. So we have some copper wires here, just like you'd see in electrical cables. I'm rubbing it a little because it's oxidized a little bit. But let's see what will happen when you drop it in. So there it is. Can we get a shinier piece, you think? What might be happening is that outer layer of oxidized copper might be preventing the reaction from from happening. Yeah, let's see if that'll make any difference. Seeing that it's gotten shinier. So that, okay. So this reaction between concentrated HCl and copper. I'm not seeing any bubbles evolving. The temperature has not changed. The only thing that's really happened is the wire looks a little shinier where it's submerged in the liquid. So this seems to be a really slow reaction where the acid can only affect the surface of the metal wire, right? It can only affect the surface little bit by little bit. So maybe over a period of time, there might be some more visible changes, but for now, not much. It just seems to be slowly eating away at the metal, but really slowly. So this was definitely the slowest reaction of the three. The fastest one was between the acid and magnesium. All right, so that's our observations for table 5. Let's move on to part. Yeah. Ugh. Where we're going to fill in table 6. Okay, so for table 6, we have 3 different acids at 3 different concentrations, and we're going to react all of them with zinc. And table 6 is for you to write your observations, okay? Sorry, was that a question? Oh. Okay, so I'm searching for pieces of zinc that are small enough to fit inside the tubes. I think I got one. All right. So we're going left to right across table 6, okay? So we're at 0.01 molar H3PO4. All right, I've added the piece of zinc. I'm not seeing it. Nope. I'm not seeing anything happening. So the reaction of zinc with 0.01 molar H3PO4, no reaction. No reaction. No visible reaction. No visible changes. All right. Let's do 0.01 HCl. Again, I'm going to put a piece of zinc in there and let's see if we can observe anything. Okay, here it is. 0.01 molar HCl with a piece of zinc. No observable changes. No visible reaction. All right. And then let's go across and do 0.01 sulfuric acid, H2SO4. Nothing doing. So at a concentration of 0.01 molar, none of the acids show any visible reaction with zinc metal. So all across that first row, 0.01 molar, no reaction for all of them, okay? Yeah, nothing. Okay, let's go down to the second row, 0.5 molar. We'll start with phosphoric acid. Look. Oh. Look. It's like so little.
It's like small bubbles.
Yes, really, really small. It is bubbling. But really slowly, really, really slightly. I'm gonna feel it, see if it's getting warmer. Nope. I'm not feeling any temperature change. It's just bubbling kind of slowly. Nothing explosive, just nice slow bubble. All right, so that's 0.5 H3PO4 with zinc. All right, let's try the next acid, which is HCl. So 0.5 molar HCl. I'm adding a little piece of zinc. And this time I'm not seeing anything. So for the reaction of 0.50 molar HCl with zinc, I'm not seeing any observable changes. The tube is not getting warmer. I don't see any bubbles. I don't see any color change, nothing. Okay. And then our third acid at that concentration, sulfuric acid. Let's add a little piece of zinc. Okay, we got bubbles. Looks more like it's fizzing, you know? Temperature change. No, but I can hear. I don't know if you can y'all hear that? It sounds like it's fizzing, like a little can of soda. So there's some bubbling going on, as you can see. And I can hear it fizzing, but the sheet's not getting warm. Okay. All right, so we're done with this concentration. Let's go down to the last row. The most concentrated acid, we'll start with phosphoric acid. It'll be this one. All right, find a little piece of zinc. Instant bubble. Can't hear anything. but the tube does feel a little warmer. So we got steady bubbling. Tube's a little warm. Screen if you want to look. All that obscurity there, that's all bubbles. Okay. Let's move on to HCl. So we have most concentrated HCl. Let's see what happens when we put in a little piece of zinc. All right, that bubbling again. I can hear the fizzing. I don't know if you can hear that. And yes, it's gotten a little warm. All right, so here's a visual of the bubbling again. 3 molar HCl with zinc. Got bubbling and a temperature increase. And I can hear some fizzing. Oh yeah. All right, our last acid in table 6, sulfuric acid at 3 molar concentration. Let's add a piece of zinc, see what happens. Again, instant bubbling. Okay, so this bubbling is a little more vigorous. Does it feel empty on the bottom? No? Okay. All right. No temperature change this time, but lots of bubbling. I can hear the fizzing again. Bubbly, 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 bubbly. Lots of gas. Anytime you see bubbling, that means the gas is being evolved. All right, so that's all our observations for table 6. So we're done with part D2. Let's move on to the last part, which is part D3. Yes, we are. So I'll leave you open. 2, 2, 3. All right, D3. We're still using those same 3 acids. We're going with the highest concentration, which is 3 molar. But this time we're trying to compare how these acids react with magnesium versus how they react with zinc. So I know there's different versions of this lab book, but for tables 7 and 8, the 2 metals that we're using are magnesium and zinc. So if it says copper in the last column, Cu, change that to zinc, Zn. All right. Okay with that. All right, let's start. H3PO4 with a little magnesium. So let's see what happens. So just like before, magnesium shows a very intense reaction with concentrated acid. There's gas, fumes coming up out of the tube. There's intense bubbling at the surface there where the metal hits the acid. And as I shake it to expose more of the surface area, the reaction will keep going. Is it warmer? Oh yes, feel that. All right, so observations between 3 molar H3PO4 and magnesium. We have intense bubbling. You can see gas fumes. We can hear it fizzing, and the tube has gotten pretty warm. So those are your observations. All right, let's see how that same acid reacts with zinc at that concentration. Is the reaction as intense? All the same observations. Or is it slightly different? Okay, there it goes. So it is bubbling, not as intensely as it did with the magnesium, but it is bubbling. As I expose more surface area by shaking it, it'll bubble more and more and more until all the metal is gone and there's nothing left to react with. I can't hear it fizzing. I cannot hear it fizzing. And it does not seem to be warmer. So no temperature change this time. Just some slow, steady bubbling. And that's really it. Okay, hope you saw that. All right, moving down to our next acid, H2SO4, sulfuric acid. Let's start with the magnesium, the reaction with magnesium. I'm just gonna add a little bit. Okay. Fumes forming. Intense bubbling. The moment it hit the surface of the liquid, it started fizzing. And it is very, it's hot. It's not just warm, it's hot this time. I'm gonna add a tiny bit more so you can see what happens like the moment it hits it. That's immediate reaction. So gas is coming out, and there's just this immediate reaction. Lots of bubble. Intense reaction, and the tube's warm. So that's the reaction between sulfuric acid and magnesium. Let's take our other thing of sulfuric acid and see if it'll react that way with zinc. All right, we got a piece. So again, an immediate reaction, just not as intense. So a less intense reaction, it is immediate. There is lots of bubbling, you can see. I'm not seeing fumes, even though we know a gas is being formed. But the bubbling is so steady, it's obscuring the liquid, you can see. I'm gonna feel it. It does not feel warm. Okay. So H2SO4 at this concentration with zinc All I'm seeing is bubbling. Lots of bubbling. I can tell a gas is being formed, even though there's no fumes and there's no temperature change. Then our last acid for table 8, HCl. 3 molar. Let's see what happens when we add a little magnesium. Again, an immediate reaction, really intense. The bubbling travels way higher up the tube than the level of the liquid. All the metal is almost gone instantly. I can see fumes forming. There's lots of condensation inside the tube. And again, it's gotten pretty warm. So it's still going, it's still going. Lots of intense, immediate bubbling. It's still fizzing, I can hear it fizzing. I can see fumes forming, and the tube has gotten warm. So energy is being released or given off as this reaction goes on. All right, so let's take our other cube of that same acid, HCl, and add a little piece of zinc to see what happens. All right, immediate reaction again. Not as explosive as with magnesium, but still steady. I don't see any gas forming, but I know that a gas is forming because of the bubbles. I can hear a little fizzing, but the tube doesn't seem to be getting warm. Right, so no temperature change for this reaction between 3 molar HCl and zinc. Just a lot of bubbling, slow and steady, not explosive, not as intense as it was with magnesium. But lots of bubbling, no temperature change, nothing else. All right, I believe that's our last, yeah. That's the end of the experiment. If you're missing any observations, check the chat. And if you still don't see it or you're not sure, ask a question or ask a classmate, whatever you're more comfortable with. But at this point, the experiment is over. Okay, if y'all have any questions, I am here. But you should have, at the very least, you should have table 2 filled in. You should have most of table 3 filled in. If you predicted the jumps, you should have table 3 all filled in. You should have table 4 filled in. Seven is another prediction area. So table 7 is where you would have written your predictions, which one is going to react fastest, or is it fastest or most intense? Yeah, it's fastest, it's slowest. So table 7, you're just going to have numbers from the numbers from 1 to 6. And it's okay if your predictions are off. That's fine. Somebody's still reacting. Yeah, all of the zinc reactions are still going. I can still hear them triggering. That's it, okay? Thank you. Have everything, you're free to go. If you have any questions, let me know. I rhyme because I'm an artiste.
All right, is that it?